Now here in this video we are going to learn a very important thing, which is nothing but handling the imbalanced data set. What imbalanced data set means, let's say if you have 100 records in total in your data set, and out of 100 only 10 are something which are having the negative flag, less rest 90 or something which are positive, for example in case of fraud detection, right? So if you remember this particular video, these videos, right, where we build a model to detect the fraud, right? So what we saw is over here we had quite unusual kind of accuracy score, where we were getting it 100% accurate, which is could not be possible. Why we were getting it? Because the data was highly imbalanced. That's why it was giving you the 100% of the accuracy rate. And when we looked at the precision, recall and F1 score, those were not too good, right? We tried different modeling techniques also, and we came up with some better result. But today what we are going to understand is how can we handle those kind of data so that it could be it could be used well in training our model, right? So what are the techniques that we can have a look? Now, before we start, let's have a quick recap on the code which we had covered in this particular video, in that particular video. So this was the code. What I have done is I've tried to recreate that over here with some lesser amount of data. So this is just because it was becoming difficult to handle it and run it over here. That's why I have just done some, I have taken some lesser amount of data. Okay, so here I have imported the data, and here I have created. So this is our data volume, which is this is the total data volume which we need to consider, right? And in this data, if you see, the total number of frauds are 8,000 approximately, and non-frauds are 80,000. So if you see, 10% is something which is approximately 10% of the total volume is fraud, rest is non-fraud. So this is where we say it's imbalanced data, which we require to balance before we finalize our model or we train our model. So what we had done previously is we did some sort of sanitization check. We checked out if there is any missing value or not, which was not existing at all. Then what we did is we dropped the categorical columns out of this data. So in this data we had the categorical column, for example this one, which doesn't, I mean, more of these were more of ID column, right? Name of origination account, from where the transfer was initiating, payment transfer, and where that amount was being transferred, right? Those kind of ID variables these were, right, which were not of much use for us. That's where we just dropped it. Next, what we did is this type, payment type. This was useful one. So what we did is we converted that into the we treated that, we did one hot encoding right over here. We have done the encoding thing for that, right? So into the data, if you will see, for each of the payment method we have a separate column created in which we will have 0 and 1 value. If you are interested in understanding that, please check out the previous video. In that I have covered that in very detail. Now, once I had this complete data cleaned and very good to use, what I did is I split that into two parts. One is for fraud, the other one is for genuine. I also did the further splitting, where I kept in one dataset I kept all the independent features, and in this one I have kept the dependent feature, which is nothing but target. Then we splitted the data in trend test split. We created model instance, which is for logistic regression. We fit the model over here, then we did the prediction of that. We did accuracy test over here, and whatever came out in the accuracy test, I tried to plot that into the heat map, which you see over here. And we also tried to print the classification report. So this is what you're seeing. Now if you see the accuracy score, we are getting 96%, right, which is absolutely in favor of predicting the no fraud. Mostly whatever you put, 96% of the time you will get that as no fraud, right? So which is not possible, which may not be possible. So that's what we are going to learn over here today. So these are some of the most commonly used techniques which are used in handling the imbalanced data. For example, oversampling, undersampling, SMOTE, k-fold, ensemble technique itself. So I'll be taking one by one each of these. Let me explain you what is what is oversampling, right? Why we should be doing oversampling, right? So let's say this is the total data volume, and this is how the segmentation is. Total data volume is 88,213. Out of is 80,000, which is not which is approximately it should not be 99%, it is 90%, 90.7%. Okay, so this is 90.7% is no fraud, and 9.3% is something which is fraud, right? So to handle this, what we're gonna do is, this is the minority class and this is the majority class. So minority class, we are going to do the oversampling for the minority class. So what we do is, so for this sampling technique, there are multiple methods. So we are going to start from the very basic level, from the beginner one, right? And over here what we do is, we are going to create the copies of, records which we already have available in our minority class. And here what I'm going to do is, it completely depends on you how many copies you want to create. For that, what I did is, I tried to make it equivalent to the genuine number of the transactions, right? So I had 80,000 genuine transactions, so, and I had just 8,000 of fraud transactions. So what I did is, I created 10 times the, I duplicated those fraudulent transactions approximately 10 times randomly, right? So that's how I ended up this many population, right? So, and that's how I have 50% balance into it, and I'll be training my model on this, and let's see how it goes. Now let me take you to the Jupyter notebook and let me show you how it works, right? So for example, over here, so what you see over here is, we have already segmented genuine and fraud, right? So let's see how many genuine transactions are there. Genuine dot shape. So these are 80,000. What and fraud transaction are, frauds are 8,213. So what I'm going to do is, I'm going to do this the oversampling for this one. So for that, there is one technique which is called simple sampling thing, right? So I'm going to call samples, and in this I need to provide the size of samples which I want to create. So size of sample I'm going to take as the total number of records which I have in genuine segment. Okay, so here I will say genuine dot shape, and out of that I'll keep the first instance. Let me show you what does this mean. All right, so you see, when you say shape, then it gives this, and then it gives this. So this one is 0th part, right? So that's where I'm getting this one, right? So this is the samples which we have, and that I can store. So this is going to be more than the total number of records. So genuine has 80,000 while the frauds are 8,213. So if you are taking uh, a sample of less than 8,000, then it is okay to go ahead like this. But here the total number which we are going to take as sample is 80,000, right? Which is higher than this. So for that we need to say replace equals to true. Replace equals to true. And this will be created over here, and I'm going to store this in this, let's say new. All right, or let me call over, frauds over, and then let me take a shape of this and see what happens, right? So you got 80,000 over here. Now what I'll do is, I'll concatenate genuine and fraud both, right? So for that I'm going to say processed, because our dataset is named as processed. If you see over here, this is the dataset, right? So I'm going to keep the similar name, processed df oversample, right? Oversampled. And into this I would say pt.concat, and inside that what I'm going to do is, I will concat both of the dataset, genuine, and over here I would say frauds over this one. All right, and axis equals to 0, which means I want to put it one below another, right? And then let's just see how it looks. Shape. So now we got 16,000 records, right? Now after that what I'm going to do is, I'm going to do a train test split on this. So train test split. So before, if you are following this this video, right, so make sure that you have all these dependencies already installed, right, already available in your data, not data but in this session. Then only you will be able to use these techniques whatever I'm trying over here. All right, so over here what I'll do is I'll do the trend test split from here, and into this it is beautifully written, so that's where I'm just going to copy from here and paste it right over here. All right, so what it is saying is trend test is split, and instead of X and Y, what I'll do is I can rather, let me put here processed over. So I need to give the X of this data set, right? So out of this, I would just drop is fraud, which is the target variable, right? So here processed, I am just assuming that you are familiar with this trend test split. So, and I'm going to take it little quick. Okay, drop is fraud, and X is equals to 1, which means the column, right? And over here what I'm going to do is I'm going to keep that part only, is fraud, and this is it. Over here test size is 33%, I'm going to make it 30%. Random state, I'll just make it true, so that every time when we run this it will take the same thing, right? And let's run do this. Yeah, it is done. Now once this is done, we need to create we already have the instance of logistic regression. I'm going to try all of these things on logistic regression only, right? If you want to use a different model, you can of course try that. So I'm going to use logistic regression itself. Okay, now the next thing which I'm going to do is I will say logit dot fit, and into this I'm going to use xtrain comma ytrain. All right, this is done. Now it will fit the model. That's done. Let's do the prediction. Logit dot predict, and inside that I'm going to put x test, and let me store this inside prediction. Oops, x test. Okay, I need to make it capital letter. X test. This is done. Now let's just try to check the accuracy score. For that we have confusion matrix. All right, what I'll do is I'll quickly copy paste this part, so that it will show us very quickly, isn't it? So I hope you are familiar with this. So I'm just going to copy paste this, and let's see what is it that we are going to get. Confusion matrix. All right, so this is how we are getting it. Now the next thing I'm going to do is I'm going to print classification report, and inside that y test comma prediction, and let's see, let me just say print over here. All right, so it's pretty good. I mean, again, it is 91%, but what you see, how is it different from here? Let me take a screenshot of this. Right, so if you see over here, the accuracy was 96%, and you remember I said if it is 96%, most of the time it will end up predicting the entry as no fraud. So the problem over here was F1 score for this class was 77, right? And now you see how it has improved over here. That F1 score has increased to 90%. It means it is quite balanced, and there will be very less possibility that your prediction will be incorrect. Accuracy has reduced. Previously it was 96%, now it is 91, and the F1 score has increased, which is 90%, right? And for this class it is 91. So you see, for both of these two classes it looks quite balanced, right? So here you are saying 91, and here you are saying 90. So it is pretty much in sync. Now the second technique what we are going to try is undersampling the majority class. What does that mean is this one. So into this, if you remember, the minority class had the number of observation 8213, right here, and this was quite huge. All right, again this number doesn't seem to be correct. this one. So don't focus on this part. Let's be focused over here. So we in fraud segment we had 8,213, and in genuine we had 80,000. So what I'm going to do that is, out of those 80,000 I'm only going to pick 8,000, approximately 8,000 random sample, and those will be my genuine volume and this will be my fraudulent volume, and I'll combine them again together and then I will train my model, right? This is called undersampling of majority class. Again, I'm not doing anything here, even I'm not making any duplicates, it's just I'm picking random samples out of the majority class. Or maybe you can also say that deleting the records to balance with minority class, right? So let me quickly do this. So this time I need to do the sampling for genuine, right? Previously we did it for fraud, now over here. And I mean, this time I'm just doing the opposite of what I did previously. You see over here what I had done. I had sampled the frauds with the count of genuine. Now I'm going to do it the other way. I'm going to sample genuine with the count of frauds, right? So let me take frauds over here dot sample, no, not sample, dot shape, oops, shape, and over here this is what, and I'll take genuine, store it into it, and let's take the shape of genuine, 8,213. So here I'm taking the number of frauds dataset, the volume which we have for frauds, that is the exact count which I'm keeping over here. But this is not important that I always keep this count. It is completely on you. Whatever numbers that you want to produce, you can put it over here. Now because I said that it is on beginner level, right? So I'm trying to keep it simple, that's why I'm keeping the same number, right? If you want, you can try it with different set of numbers. Now again I will do the concatenation, pd.concat, and inside that again what I'll do is I'll put genuine. Oops, I made a mistake over here. Let me quickly correct it, otherwise that will be a problem. Please bear with me for this mistake. Now over here I'm almost done. All right, so over here I should say genuine under, right? So I should create a separate data set instead of overwriting the previous one, right? So let me just take genuine undersampled comma frauds, this one, and here I'm going to say axis equals to 0, and what I would say is process data frame. I'm going to create another one, and this time I'm going to say it under. All right, now let's just say shape. What is the shape? This 16,426. Now let's try to train the model. I mean, first we will do the trend test split. So this time I'm going to copy paste it from over here. All right, this will save our time, nothing else, right? And just all that we need to do is just change the dataset name over here, data frame name, this. All right, and let's just try to train our model, not train but they split. Then it is done, split is done. Then I'm again going to say call my model, lock it, and inside that I'm going to put x train and then y train model.fit. Sorry, model.fit is done. Then after it is pretty quick because the number of records were quite less, right? Now I'm going to do the prediction, log it dot predict, and inside that I'm going to put x test, and this I will store in prediction over here. Now again what I'll do is I'll copy paste the things from here, right? Because everything I'm keeping the same, right? Name nomenclatures are absolutely same, accuracy, taste, etc, etc. Now let's just run this. Okay, and now let's print the classification report. Classification report, inside that I'm going to put y test first and then prediction, and let's just see. Oops, let me print it again. All right, so it seems like giving the similar result as we had over here. So accuracy over here was 90%, right? Over here the accuracy was 90%, and over here the accuracy has increased slightly again, but it looks more or less same. So you see undersampling and oversampling. This is how you can treat your data with undersampling and oversampling. Now I see this video is becoming a little longer, so what I'll do is I'll cover this SMOTE in the next video, right? So stay tuned with me. Let's catch up in the next one and try to understand what SMOTE is.